Welcome back, Math 6. This is Chapter 4, Section 1, entitled Greatest Common Factor. So, to begin, you have Venn diagrams. Use overlapping circles to show common elements. Factors that are shared by two or more numbers are called common factors. The greatest of the common factors of two or more numbers is the greatest common factor. So, find the greatest common factor of 36 and 48. You first make an organized list of all the factors for each number. So, you basically set this up, and I personally don't like the way it's written here. I think it's difficult to see. I would say that 36 is 1 times 36, is 2 times 18, is 3 times 12, is 4 times 9, and is 6 times 6. These are all of the factors. 48 would be 1 times 48, 2 times 24, 3 times 16, 4 times 12, no 5, 6 times 8. So these are all of the factors. 1, 2, 3, 4, 6, 8, 12, 16. Going in this direction in numerical order. All right? Now the common factors are, I'm going to circle them over here. So obviously, common factors are 1 and 1. 2, 3, 4, 6, 12, and that's it. So the common factors are 1, 2, 3, 4, 6, and 12. And the greatest of these is 12. So the greatest common factor of those numbers is 12. So look at 45 and 75. Factors of 45 are 1, 45, not 2, 3, and 15, 5, and 9, and that's it. I can't think of any other ones that are in there. Maybe 6, maybe 7, maybe 8. As soon as these numbers here get close, so I'm going to just kind of add a little note here. When these are close, you are done. Right? 5 and 9 are pretty close together, so you can be done. 75. 1, 75. 3 and 25. 5, maybe 15. 6 doesn't. No. So this is it. So let's circle the common ones. 1, 3, 5, 15. So the common factors are 1, 3, 5, and 15. So the greatest common factor is 15. All right. Remember, this is something from earlier on. Remember that prime factorization is writing a composite number as a product of prime numbers. So remember that 12, 2 times 6, 2 times 3. So my prime factorization is 2 times 2 times 3. All right, find the greatest common factor by using prime factors. All right, write the prime factorization. So write the prime factorizations. Well, that's 2 times 26. 26 is 2 times 13. 78 is 2 times 39. And that's a 2, and 39 is 3 times 13. So 2 and 13 are common factors. So 2 and 13 are common factors. All right. Now the other method. Divide by prime numbers. All right, so let's see. So I'm going to put 52. So you're going to put, I think the way this is set up is kind of messed up, but you're going to divide by 2 here. And 52 divided by 2 is 26. 52 divided by, that's 39. Then you're going to divide both by 13 maybe. Using either method, the common factors are 2 and 13. So the greatest common factor of 52 is 2 times 13, or 26. All right. I personally think the using this as a method is very good as well. So basically what you can do is you can make a factor tree, or write down all of the factors, or do a factor tree, do a composite, and then whatever they have in common, you multiply them together. So the common factor is 26. So greatest common factor of 64. We're going to do it 2 different ways. We're not going to use this whole division method because that is very complicated and I think confusing. So first, let's try that first method. 64 is 2 and 32. I'm sorry, 1 and 64, 2 and 32, 3 and, oh, not 3. 4. All right, so I went ahead and paused the video. I wrote down all of the factors of 64 and 80. These are all the different possible factors of them. Now the common factors are 1, 2, 4, 8, 16. 1, 2, 4, 8, 16. The greatest of them is 16. So this is a way to find the greatest common factor. Now, if you're afraid you're going to forget some of the factors, you can do a factor tree. 64 would be 2 times 32. 32 would be 2 times 16. Let's do 4 times 4. Okay, that's for 64, prime factor tree. 80 is, I'm going to do 8 times 10 this time. I'm going to do 2 times 4, and 2 times 5, 2 times 2, 2, 2, and 5. So, what I have here now, let me see if I can make some space here. All right, what we have now is here's a 2 in common with a 2, a 2 with a 2, a 2 with a 2, and a 2 with a 2. These ones are not in common, all right? They match up. And so together, we have 2 times 2 times 2 times 2, which is 16. All right, I'm going to scroll back here real quick and look at these two right here and talk about how a factor tree would work for this. 45 is 9 times 5, 3 times 3 times 5. 75 is 3 times 25 and is 3 times 5 times 5. So when I look, here's a 3 in common, here's a 5 in common. 3 times 5 is 15. That is what the greatest common factor was over here, 15. So prime factorization should help. Now, why is the greatest common factor of two prime numbers always 1? This is the reason for this is that the definition of prime numbers so prime numbers factors are only 1 and itself. So 3 and 5. They're both prime numbers. The only factors are 1, 3, 1, 5. So the only numbers that prime factors could even possibly have in common are 1. All right, I think we're almost done. Anna sells bags, different kinds of cookies, $27, $18, $45. We're trying to find what is the most that Anna could charge for each bag of cookies. 18 factors are 1, 2, 3, 6, 9, 18. 27 is 1, 3, 9, 27. And 45 is 1, 3, 5, 9, 15, and 45. So if you haven't written all these down yet, pause the video, write them down, unpause, and now we're going to look at what the common factors are. So the common factor, if you look at all of these, the greatest common factor, well, they all have 1 in common. They all have 3 in common. They all have 9 in common. So the greatest common factor is 9. So the most she could charge for each bag is $9. How many bags can Anna have sold if each bag costs $9? Well, 27 plus 18 plus 45 is 90. So the number of bags is $90 divided by $9 and a total of 10 bags. All right, so let's take a look at this. What is the most that Sarah could charge? What is the most that Sarah could charge if she was selling these kinds? Well, 24, 40, and 60. Greatest common factors. Well, let's write them all down. 1, 2, 3, 4, 6, 8, 12, and 24. 40 is 1, 2, 4, 5, 8, 10, 20, and 40. 60 is 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. So all of those factors, 1, 2, oh, not 3. So 1, 2, 2, 4, let's see, 8, let's see, 12, no, 20, 20. It looks like the greatest common factor, hold on. Oh, shoot. Hopefully you said, hey, Mr. Andre, you did something wrong. I wrote all the factors correctly, but I wrote the number down incorrectly. So it's 64. So I messed up. I'm sorry. So it's 1, 2, 4, 8. Okay. And now the ones they have in common is the greatest common factor is 8. So how many boxes could they sell for $8? Well, we add up 24 plus 40 plus 64, just like the example. And you get 128. You divide by how many dollars per bag you do it, you get 16. All right. So practice some. All right. Make sure you fill out this part of your homework assignment. All right. Pages from 4.1 and exercises right there. All right. You then should be doing your CYUs. Don't forget. Good luck.